Morning, Rainey. Morning, Ryan. Morning, Eric. Morning, Hayden. Morning, Downey. Hi, Jack. You guys doing good? Hi, Sophia. Hi, Kim. No. That's good, Eric. You finish at 12 each day. Is that good? Well, you think about it, you get 4 core classes a day in school. They're only 50 minutes each. So that's 4 hours of being in class. And then you have, your electives, obviously, but then lunch. One, all right. Are you constantly working from 9? Because then that puts you at about 4 hours. I think if you guys are finishing around 12 or 1, that's good. If you're going into like 2 or 3, you're still doing those 4 main subjects. Kind of look at how you're working. Of course, you can take breaks throughout the day. I go to 3, 9 to 3. Also keep in mind there's Win and Act Lab too that you had in school to do work, but then there's homework too. Hi, Aiden. Hi, Ezra. Yeah, I mean, being distance learning, you guys can work at your own pace. You can work at 6 in the morning, you can work at noon and catch up. Alright, good. That was weird. Should be fine though. Alright, let's get into today then. First thing, just kind of hit on. Roll Tide should have been done. It was returned to you. If you want to fix your score, I think the biggest thing to do is going to be going back to Tuesday, looking at this comment, and then seeing that we did the DNA at around minute 45, and then we did a diagram of the tides at minute 12 from that stream, and fixing the questions towards the end of the document, which were worth 2 points apiece. So if you didn't have enough detail or you didn't explain it the way we talked about in stream, I would do that. I'd go back and I'd fix that. All right. The other questions, if you got it wrong, I just quickly deleted the answer. You can go back, you can fix it. So a lot of the times people were just mixing up high tide, low tide in the explain section, or they were off by some hours earlier in the explain section. All right. So if you want to revise roll tide, you just fix it, you just resubmit it. You guys got a week. And then your online DNA sheet, that's due. I got to refresh Classroom. Due today before midnight. All right. So I'll be taking a look at that later on. You submit it early, I'll take a look at it early. If you want the extra time to get it done before midnight, take it and then submit it, and I'll look at it tomorrow. All right, you guys do have your weekly quiz tomorrow, so your agenda is going to be going into your key term guide tomorrow, doing lunar eclipse, doing tides. The second part would be doing the quiz, and the third part would be doing a little bit of the extend section of modeling eclipses. All right, not all of it. You know, Eric, you can be easily removed if you can't behave. Ooh, I can put a user in timeout. That's pretty cool. Or hide user. Let's not get to that. All right. Okay. So, DNA question. You can start working on it right now. I'll come back to it towards the end. What is low tide? What is neap tide? Provide the sun, earth, and moon alignments for both. So it's very similar to yesterday's question. Yesterday was just what's high tide? What's spring tide? Today you're doing low tide, neap tide. Same format. So if yesterday I said we did the DNA at minute 54, I can click the YouTube video, get to minute 54. I start kind of writing out the answer. So there's yesterday's DNA. I asked what's high tide, what's spring tide. So do the same kind of format. Type out your definition for this time, low tide, and instead of spring tide, neap tide. Yeah, Hayden, do the self-rating right there on the DNA sheet. I think the boxes are formatted large enough so I can see the letters. So you're doing what's low tide, what's neap tide in your DNA sheet for the last box. What's the sun alignments? You can just tell me in words, describe them what the alignments are. But if I go back to yesterday, clearly I'm looking at right here in this picture that for a high tide, I need to have the moon, myself, and the earth all in a straight line to have a high tide. Either I'm on the side closest to the moon or I'm on the side opposite the moon, because the moon pulls water to itself, but then it can't reach all the way to the backside, which means some of the water snaps back to the opposite side of the moon and leaves two high tides on the planet. All right, where the water is getting pulled from becomes low tide. So to be high tide, I have to be in line with the moon, the earth, in a straight line. All right, to have spring tide, it's similar, except we add in one more object. To have a spring tide, I can be anywhere on the earth. I'm just going to have a higher high tide and a lower low tide, but the sun, the earth, and the moon will be in a straight line. So high tides and spring tides work by being in a straight line. For a spring tide, you just add the sun. Okay? We're not really talking about the sun when we're talking about generic high tide. All right? Logan asked, we're going to post review picture. I will be posting review pictures later today. Yes. All right, it'll be a separate post from a daily post, just like typical. I'll post the DNAs for Monday, Tuesday, Wednesday, and Thursday, and then I'll post spring tide versus neap tide, and I'm going to post the diagram of the tides. I didn't do that throughout each day because I wanted people to go back, check the stream, get a little extra help if they needed it. But I'll post the actual pictures later. Yep, you're welcome. So I'll come back to that towards the end. Next, what we're going to do, we're going to review the Explore section of Modeling Eclipses, and then we're going to complete the Explain section. All right, and they'll be mostly on your own, but I'll kind of point out what you're kind of looking at. It's shorter than the Explore section. All right, I think the Explore section is going to be the longest out of Modeling Eclipses. All right, so this is what you were working on yesterday. Getting into eclipses. All right, figuring out what phases each eclipse response is the result of. You had to allow flash. All right, I went through the steps in yesterday's video. I might have to read it. No, good here. I'm going to pause the simulator for a second. and then go down to number 1. All right, we'll quickly just go through 1 through, I believe, 10. Yep, 1 through 10, and then you guys will have time to work and ask questions on the extend section. All right, or explain section. Number 1, where is the moon during a solar eclipse? Where is the moon during a lunar eclipse? So I unpause the simulator, and I'm just taking a look. An eclipse is the blocking of one object by another. So here comes the moon. It's almost making it look like the sun is waning, right? It's like almost a waning crescent right there. And there's our solar eclipse, okay? That is totality. That is the moon blocking our view of the sun. And it's not the entire planet. If you notice right there, we're just the blue triangle. So you can only see the shadow of the moon as it falls on your location of the Earth. It's a very small object, and so it casts a very small umbra, or a very small direct shadow. Okay? If you are in the penumbra, right here it says penumbra not shown, penumbra is the indirect shadow. So if you were in a partial eclipse, you see something like that. You know, it'd be a little misaligned, and you wouldn't see the total 1-to-1 aspect ratio of the moon to the sun. All right? So that's a solar eclipse. And what the question is just literally asking you is what phase, or where is the moon? Phase is later. I got ahead of myself. So I go here, and the moon is between the Earth and the sun. So where is the moon during a solar eclipse? It's between the Earth and the sun. Okay? Where's the moon during a lunar eclipse? Well, I bet it's going to be the opposite, huh? So I put it over here at this node, and it's going to pass that node, it's going to flip. So now we're looking behind Earth. You're looking out to space, view of space from Earth. Drag the moon a little bit further. All right, now the moon's entering the Earth's umbra, direct shadow. Getting darker until it doesn't, and that's pretty interesting. It's getting red. We'll talk about that as we finish modeling eclipses. Why does the lunar eclipse cause the moon to look red? And there's totality. It's in the Earth's shadow, right? It's been in the Earth's shadow. And so now we know for a lunar eclipse, see, I can click solar eclipse, I can click lunar eclipse, and if I unpause it, it just shows you that for both, where they belong, the moon belongs behind the Earth and the sun. Yeah, sometimes it's called the blood moon. All right, so the moon is behind the Earth and the sun. All right. Second question, totality is the time during which one object completely blocks the sun to the other object. That's, again, kind of going to the definition of eclipse. Which has a longer totality, solar or lunar? All right, well, which one lasts longer? Literally. There's totality for the solar eclipse. 1001, 1002. It's even less than 2 seconds. It's maybe like 1 second on the simulator. That's not in real life. All right, but just the simulator, it's like a second. So now you let the lunar eclipse go. How long does its totality last? Here comes the moon, crossing into the Earth's shadow. We'll call that totality 1001, 1002, 1003, 1004. So it's like a little over 4 seconds on this simulator. So which one literally lasts longer? Well, I'm going to say it's a lunar eclipse. All right. I mean, why might that be? Well, because the Earth's a bigger object, has a bigger shadow, so it takes longer to go through. All right. 4, why do these phases make an eclipse possible? Why do the first and third quarter lunar phases not result in eclipse? So I skipped over 3. What is the phase of the moon during a solar eclipse? And then what's the phase during a lunar eclipse? So if I go to totality, what's the phase right here? That's new moon. All right. Go to lunar eclipse. What's the phase right there? Full moon. So it's either got to be new moon. Again, the moon's close to the sun, so it's new moon. And then opposite new moon is obviously going to be full moon. So lunar eclipses are always full moons. Can never be a different phase. If you're going to have a lunar eclipse, it's going to be a full moon. All right. If you're going to have a solar eclipse, it's never going to be another phase. It's always going to be new moon. All right. So why do these make these possible? Because new moon and full moon allow for the perfect alignment. Sun, moon, earth, or sun, earth, moon. So those two phases allow for a perfect straight line between those three objects, the sun, the earth, and the moon. Okay? That's the only time you're going to get an eclipse. All right? And yeah, you'll get a spring tide during an eclipse. All right? You'll have a higher than normal high tide. You'll have a lower than normal low tide because you have that straight alignment. Okay? See how the phases and the tides and the eclipses, they all kind of come together now? All right? So why the first and third quarter not result in eclipse? Well, then it's just the opposite of what I said. It makes a right angle. You can't eclipse anything. You can't have an object. You can't have the moon blocking the sun, and you can't have the earth blocking the sun to the moon if they're not in a straight line. So they gotta be in a straight line, or 180 degrees. But here, if they make a right angle, they're not gonna be in a line. All right, and that's just what I mean by use angles in geometry. I mean, we have to be in a straight alignment for an eclipse to be possible. First and third quarter are at right angles, and they do not allow an eclipse to happen because they're not in a straight line. Okay? The next set questions just look at the different variables in the simulator. So playing with the sliders here. Tilt of the moon in its orbit, the Earth-Moon distance, and the size of the moon. So 5, set the tilt of the moon's orbit, the first variable on the right, to 3 degrees. Observe the effect. Describe and explain what happens to each eclipse. So this is just more of just description and observing. Okay? So kind of set it here. Gotta let it do one complete rotation. I'm going to kind of speed it up though, for sake of time. I'm going to let it run. Again, we're at a 3-degree tilt, so you can look at the side view. The moon's a little lower than it would be normally in front of the Earth. Moon's coming in, passing over the triangle. Wait a minute, nothing. So the moon's a new moon, but it did not pass in front of the sun. We did not have an eclipse. All right, same deal. We'll go over here. The moon move. There's the moon. It's in full, but it is just grazing the Earth's umbra. You can kind of almost call that a partial lunar eclipse or a penumbral eclipse, but still not a full eclipse. So what happened? There was no solar eclipse. There was a partial lunar eclipse. Just describing what happened. The moon was not in line, perfect alignment with the sun and the earth. All right, and then you set it to -3. So now we go the opposite direction. Again, you can't get it perfectly to 3. Do the best you can, get as close as you can. Let the simulator go. And if it missed it the first time, it's going to just miss it again. All right? And so it's kind of almost a repetition of what happened before. Here comes the moon again, behind the Earth. Again, like a partial lunar eclipse, if you can even call that a partial lunar eclipse. There's the outline of the Earth's shadow. All right? Not passing through the center of it. So then number 6 is just kind of just a repeat. Okay? That the effect is that there are no solar or full lunar eclipses. The moon is not in a perfect straight alignment with the sun and the earth. Okay? And so now we go to number 7, number 8, and yeah, the question came up, do I then just change the distance now, leaving the tilt? No, you got to refresh it. You can only change one independent variable at a time, right? So we're going to refresh. The sliders go back to their default. The moon's still moving. I'm going to pull it back a little bit. I'm going to now change the distance. So set the Earth-Moon distance to 353,000 kilometers. That is just the shortest distance. I just pulled all the way to the left. All right, let the simulator go. So now we're closer to the Earth. What happens? The moon's going in its counterclockwise orbit. And the sun is almost completely blocked. So if you kind of go back to the original default, That's what it looked like originally, roughly. This is what it looked like when the moon is closer. So the moon looks larger when it's closer. Gee, couldn't figure that. If something's closer to you, it appears bigger. So this is all about aspect ratios. All right, the moon is tiny, but it's much closer than the sun, and so the aspect ratio is actually 1 to 1, which is pretty rare in our solar system to have something like that. All right, so this makes the moon look larger and almost completely block any kind of outline of the sun. All right. Fun fact, the only time you ever see the atmosphere of the sun, the corona, the hottest part of the sun, not the surface, is during totality of a solar eclipse. All right. We'll take looks at pictures of those in the next couple days. Pretty cool. All right. Let it go in its full revolution. See what it looks like when it goes near the Earth. The moon just looks bigger. It's still red. It's just still a lunar eclipse. Okay. So I go back. What happens to the distance? What's the effect? You still have a solar eclipse. You still have a lunar eclipse. The moon looks larger, completely almost blocks the entire part of the sun, and then it just looks larger during the lunar eclipse. All right. So that's, I mean, hopefully kind of obvious. I mean, the closer it is, the bigger it is. Right. You still have the eclipses though. So far we found out that the tilt is really what's going to change whether there's an eclipse or not. All right. So let's make the distance maximum. Go with the sun. And kind of just the opposite. If it completely blocked it before, it's much smaller against the sun now, and it's not really much of an eclipse. I mean, it's still, you see the outline of the new moon, but I mean, it's not completely blocking the sun. Go into the Earth's shadow now. And it's still, because the Earth's shadow is so large, it's still going to be a lunar eclipse. Okay, full moon. So the effect here, the distance, making it the largest it can go. All right, it basically becomes a partial solar eclipse, but it stays a lunar eclipse. Okay, because it's small, it ruins the aspect ratio with the sun. All right, you don't have that problem with the Earth because the Earth is so large compared to the moon, and so you still travel through the moon's very large umbra. It would probably actually make the lunar eclipse happen a little longer too, because the moon's smaller, and so it would take more time to have to go through the entire shadow of the Earth. All right. And so now we'll change sizes of the moon. All right. 50% for number 9, and then 150% for number 10. So 50% for 9. Let it go. And you can kind of even almost guess what was going to happen. I mean, if we change the distances, then if we change the size and make it smaller outright, then it's not even going to be a solar eclipse. Okay, you see the outline of the new moon still, but it's not eclipsing the sun. This is not an eclipse. This is something more called a transit. All right, a transiting object is moving in front of a star. You can see the outline of that object. We see this happen with the other planets. So like if I do a Mercury transit, you can like find these pictures or these videos. There's the outline of the planet Mercury across the sun over time. All right, it's pretty cool that this tiny, tiny, tiny thing is a planet. In the background, the backdrop's a star, our sun. All right, it's incredibly tiny. Yes, John. All right. Or because you can only use this when there's an object between us and the sun, just like the moon. You can also do the other inner planet, Venus. Obviously a little larger. This is a cool shot. You got a plane there with, oh, another YouTube video. You got a plane there with Venus in that one. All right. And so there's the outline of Venus. All right. A little bigger than Mercury, but still tiny compared to the rest of the sun, which is pretty cool. All right. No, we can't see transit of any other planet But the other planets could see a transit of the Earth, and they could see a transit of Mars. If you're Jupiter, you'd see all the inner planets transiting in front of the sun at some point. All right. If you're Neptune, you'll see Jupiter and Saturn transit in front of the sun, because all the planets roughly are on the same plane. They're all on the same flat level, roughly. Okay. We'll talk about some of the outliers in the next couple weeks. It's kind of cool to see that. So really, this is not an eclipse. This is a transit of the moon. All right. So now you let it go towards the Earth. I'll unpause it. Still a lunar eclipse. Again, because the Earth is so large. All right. So which ones is most common is kind of what you should be seeing. It's easy to get the lunar eclipse. It's hard to get the solar eclipse. So which one's more common? It's going to be the lunar eclipse. Solar eclipses are incredibly rare. All right. As you're going to find out later on in this document, we're going to do a little bit of research. All right. When's the next eclipses for Coventry? All right. Set the size of the moon to 150. All right. Make it a little extra large. We'll do solar first because that's what it's asking. Completely blots out the sun. That is the biggest solar eclipse you'll ever see, but you don't get to see the outline of the new moon. It just kind of blocks out the whole view. All right, you don't get to see the actual shape of the new moon. Lunar eclipse, if it's going to happen. I mean, it's still smaller than the Earth, so we should still at least see totality. But is it bigger than the shadow? That's what we got to look at. Nope, just under. So here, for number 9, we do not have a solar eclipse. We have a transit of the new moon. We still have a lunar eclipse. 10, we have a solar eclipse. It just blots out everything. And then we still have a lunar eclipse. So for most of these, we still have a lunar eclipse, except for 5 and 6. So the tilt is probably the biggest effect you're going to see in terms of these eclipses. Okay? Distance and changing of the sizes, that's not really going to change the lunar eclipse much. All right? But it is going to change solar eclipses. All right? So a couple takeaways right now we can figure out is, one, the tilt has a dramatic effect on whether there's going to be an eclipse or not. That's number one. That's huge. The tilt is the primary way you determine whether there's going to be an eclipse or not. Okay? Then the other two, if you change the apparent size of the moon by either making it closer or further, or you actually make the moon bigger or smaller, you will ruin a solar eclipse, but you'll always have a lunar eclipse. So lunar eclipses are more common. So that's the two takeaways I want you to get from these 10 questions. Number one, the tilt of the moon's orbit has a major effect on eclipses. And then the second part is lunar eclipses are more common or easier to set up than a solar eclipse, because the Earth is so large that makes a very large shadow for the moon to move into. Okay? Those two big takeaways right there for this kind of explore section, exploring this simulator. All right? John's asking what causes supermoons or blue moons. So a blue moon first. A blue moon is just the second full moon of a month. Right? So think about it carefully. It takes a lunar cycle about 28, 29 days to complete. Most months have 30 to 31 days. Right? So if you have a full moon happen in the beginning part of the month, or you have a new moon happen at the very start of the month, you have a couple days left over, you might get another full moon. So if you have a full moon on the first, second, or third of the month, you could still have the whole lunar cycle happen and have a full moon at the end of the month. And so a blue moon is just a second full moon in the same month. So that's why people say once in a blue moon, because blue moons are rare. All right? You can predict them, they don't happen on a regular pattern. All right? Some months have them, some months don't, depending on where the cycle is at that time throughout the year or previous year. All right. What's a supermoon now? I kind of go back to the simulator. This is a perfect circle, right? Orbit of the moon. The moon doesn't have a perfect circle in its orbit. You gotta kind of picture it as almost an elliptical. Oops. Let me get my Chromebook back up so I can draw. Tell me your question in a second, Jake. I must have missed it. Oops. Give me 1 second to get this back up. You wouldn't be really screwed. The planet would be fine. Life on the Earth wouldn't be fine. Not dead, I'm just putting something back up on the screen. I'll have to restart my Chromebook. Oh well, so just kind of, maybe I'll come back to it in a second, but this is not a perfect circle, so in an ellipse, you'll have a point where the moon is closer to the Earth, and you'll have a point where the moon is further from the Earth. Perigee and apogee. When the moon has a full moon happen at its closest point, then you'll have a supermoon, and it'll look slightly larger. You know, instead of 150, maybe 100%, it'll look 105%. It'll look slightly larger because it's a little closer to the Earth. So I should actually be using this instead. Look a little closer to the Earth. All right. So supermoon is just when a full moon coincides with being the closest to the Earth in its orbit, because orbits are not perfect circles. They are elliptical. They're like slightly egg-shaped. All right. If you stopped rotating, you would be a day would last 1 year, and half the planet would receive too much more sunlight than it could. You'll have a massive convection current on one side, transferring wind and energy to the other side. So at the border of day and night, you'll have massive, massive windstorms, hundreds of miles per hour, and the other side of the Earth would not get sunlight, and so it would be catastrophic to the ecosystems. So really, in the dark side, you would have no life. In the day side, you might have some life, but it'd be too much sun for most life. And then at the border between day and night, you would have massive windstorms that would make life pretty much impossible on the surface of the Earth across the entire planet if you stopped. All right. Jake, what was your question earlier? Because I missed it. Different? What are you talking about? Rainy, those aren't complete sentences. I don't know what you're asking me. So here's Earth. Not a perfect circle for the moon. Moon's moving in its counterclockwise orbit. If the sun is over here, if the closest part of the orbit coincides with full moon, you'll get supermoon. Okay. Would a bigger moon affect the tides differently? Yes, the bigger the moon, the more mass it has, the more gravity it's going to have, the stronger gravity it's going to have. And therefore, the more extreme the tides would be. All right. Good question. So, eclipses. Hopefully you're all good on that. You need further help, email, remind. All right. And I'll help you the best I can. All right. The explain section. This is kind of like what you're working on today. 11, 12, 13, just 3 questions. Okay? Kind of like what ifs. What would you see on Earth during a solar eclipse? What would you see if you're an astronaut on the moon during a lunar eclipse? So, what would you see on the Earth during a solar eclipse? If I set this back to default, I mean, it's kind of in the description. This is the view of the sun from the Earth. This is what you would see if you're on the Earth. The harder question is going to be now, what would you see on the moon looking at the Earth during a lunar eclipse? The moon is red, darkish, reddish, orangey, right? What would you see on the Earth if there's a reddish, orangey glow casted onto the moon? Remember, the moon doesn't make light. Where does this red, orangey hue come from? What would you see back on the Earth to give this red, orangey hue? All right. See if you can kind of figure that on your own. We'll come back to that tomorrow. All right. 12, sorry. The actual tilt of the moon's orbit is about 5 degrees. How would this affect eclipses? All right. So you can't set it to, well, you can set it to 5. I thought you couldn't. So you set it to 5, and you run the simulator, and you tell me what happens to the eclipses. And keep in mind, if we had no eclipses at 3-degree tilt, negative or positive, we didn't have eclipses, what's going to happen here in 12? Right? 13. Even with this tilt, eclipses still happen over time. So it's kind of alluding to the fact that in 12, you're not going to have any eclipses. All right? But we still have eclipses. They're just really, really rare. They're a rare phenomenon. So how do they still happen? Okay? Just like how, John's question asked about supermoon, and that, make this a little thinner. The moon's orbit is not a perfect circle. It can be here, it can be here, right? Closer to the Earth, here. Further from the Earth, there. Well, the tilt and the orbit can also kind of wobble a little bit. So as the moon is revolving, sometimes the ellipse isn't like this. Sometimes the ellipse could be instead like this. Or it could be a little off center up to the upper right, or it could be off center up top. And so that's why supermoon doesn't happen all the time at full moon, because perigee and apogee, the closest furthest points in the orbit of the moon around the Earth, we're not going to define what those are, right? Just understand that it can be closer or further, that can change over time, okay? And therefore could tilt actually change over time too. So if this is a side view, and here's the moon, our tilt can go back and forth throughout the entire year or several years. It can change over years. So if this is a 5-degree tilt, that can change over years to the point where you're somewhere on Earth and the moon's going in its orbit and the tilt is changing and going the other direction, that it just so happens to coincide for you to happen at 0 degrees. And then that will hopefully, or maybe a little less, that will hopefully create a more total eclipse. For your self-ratings on your DNA sheet, you are using letters because that's what you're going to see on your report card. Don't use numbers. Numbers are being phased out if you haven't already realized. We haven't used the ASFMS 1 through 4 all year. You guys use numbers to annoy me, I'm going to take a half a point off. Mr. Howman just wants to stay with his numbers. I get it because it's comfortable, but you don't get those on your report cards anymore. So that was looking at the explore section. That was kind of just quickly going through the explain section. There's only 3 questions. There's not much more to do. All right, kind of already went through a couple of them. Kind of leads you to the answer. All right, I'm going to go through the DNA and then just kind of wrap up. I will be again posting. Howman's doing letters now, huh? Good. All right, good. I'm glad he realized that. So I'm going to kind of do the DNA and then we'll just kind of wrap up. All right. I will be posting pictures of the notes, all the notes. So Monday through Thursday, plus the 2 diagrams we did for spring tide, neap tide, and then the tides around the Earth too. All right. ABC and stuff. You don't get ABC for your learner qualities, man. It's like 2 steps forward, 1 step back. All right. Let's do this so you guys can actually see. I'll get out of your way. We're talking low tide and neap tide. Again, if you have this, good. You don't, you want to add to it, definitely add to it. Taking a picture of my diagram does not count as an answer, by the way. Yes, my self-ratings are EPIM. Because again, that's what you get in your report card. Exemplary, proficient, emerging, no, improving, then emerging. Ms. Kildoff wants to know where the DNA is. Your DNA is in the nucleus of your cell. Our daily known answer sheet. Thanks, Rainey. Classwork, references, DNA sheet number 22. 2 people in period C have turned it in already. It's our weekly sheet killed off. I just renamed it a couple weeks ago. They do their little warm-up question in each box. Where am I? There I am. Okay. So I let them work on it in the beginning part. Ms. Kildoff. Now I'm just kind of reviewing it. I normally review during class anyway. All right. But I'm letting them work on their own first. And then as they hopefully finish throughout our little stream, then I'll confirm with them, correct them. So low tide is I'm kind of writing fast, but decrease in sea level due to the moon pulling water to itself at another part of the Earth. All right. So low tide is a decrease in sea level due to the moon pulling water to itself in another part of the Earth. Okay. Again, there are 4 tides a day. There are 2 low tides every day. They happen 12 hours apart. Each tide changes every 6 hours, right? This is a daily thing. Okay, so low tide is daily times 2. Neap tide is monthly, but also times 2. So neap tides happen monthly during the full, not during the full moon, during first quarter and third quarter. All right. Did I go over the explain section? I mean, I did for like a couple minutes, Rainy. Unless you missed it, you can go back in the stream. I'll probably mark where I looked at it. All right. So neap tide is more minimal tides throughout. That's too messy. Let me rewrite that. TARDIS, I'm more of a DeLorean guy. More minimal tides throughout the day. This means a lower high tide and a higher low tide. So they're more minimal. There's a minimal difference between the sea level compared to a normal day or compared to a spring tide where the change in sea level is crazy. Okay? So more minimal tides throughout the day. This is monthly times 2. Happens in alternating weeks because it's got to happen with the first quarter and the third quarter. Okay? Oh my god. That says during, by the way. Alright, so that's just some simple definitions just to keep in mind. Yes, I will be asking about a definition or two on the weekly quiz tomorrow. But now the alignment. So what kind of alignment do you need? For the low tide, you need a right angle between the moon, you, and the earth. For a neap tide, you need a right angle, but it doesn't matter because the tides are just changing out the day. You're not included. In a neap tide, because monthly, you're looking at the sun, the earth, and the moon being at a right angle. So today, talking about right angles. Yesterday was about straight lines. High tide and spring tide need a straight line between the objects. For high tide, it's between you, the earth, and the moon. For spring tide, it's between the sun, earth, and moon. Today, it's about right angles. Low tide, you need a right angle between you, the earth, and the moon. And for a neap tide, you need a right angle between the sun, the earth, and the moon. All right, so just a couple examples here. It's a top-down view. My axis is a dot. It's not a line. I would put the monthly thing in, Ryan. Keep that in mind. You don't have a neap tide every day. All right. The Borg. Draw the moon in. Moon's pulling water to itself. Water's got to come from somewhere. Doesn't reach all the way around because gravity's weak. Okay. This becomes high tide. This becomes high tide. This becomes low tide. This becomes low tide. So how do you get low tide? You just be at a right angle. Be over here. Okay? 90 degrees. Okay, that's how you get low tide. How about neap tide? I'll draw the moon in the same... No, I'm not going to draw the moon in the same spot. Moon's going to go up here. And I'm going to add in the sun. So we're not going to draw you this time. We're going to add in the sun. Okay? So the sun has a high tide and a low tide too. Again, it's just very small because the sun, while it has a lot of mass and therefore large amounts of gravity, it's very far away. And gravity is affected by mass and by distance. The higher the mass, the bigger the size, the more gravitational pull it has. However, gravity also gets stronger the closer it is. So if something's really big but far away, it has weak gravity. If something's really small but very, very close, it's going to have a stronger gravitational pull. That's like with the moon. All right. If something's large and close, like the Earth with you, you feel that tremendously. All right. That's why you're on the ground right now. Okay. So moon's high tide, it's larger, greater impact, right? So there's the moon's high tide. And there it's low tide. And blue will be the moon. Right? But now here comes the sun. For the sun, its high tide would be here. And then on the backside of the Earth. And its low tide would be there. And low tide would be there. So the sun cancels out a little bit of the high tide and adds that water that it normally would have to the low tide on Earth. So the sun isn't completely changing the tides. It's not canceling out the tides completely. It's just taking a little bit away from the moon's effect and adding it to the low tide. And so that's where you get the minimal tides. All right? So for the sun, that's low tide. And then this is high tide. Okay? And just to show you, again, we're looking at right angles. Yesterday we were talking 180 degrees, straight line. Today this is 90. Okay? So low tides and neap tides happen when there is a right angle. For the daily tides, it's between you, the Earth, and the Moon. For a neap tide, it's between the Earth, the Moon, and the Sun. You're not included because a neap is an effect on all the tides. It's kind of misleading. We call it a neap tide. Well, that kind of sounds like it's a tide during the day. No, neap is the effect on the tides. All right, I'll try and emphasize that on the weekly quiz as best I can. All right, so this is the DNA for today. Any questions on it? Shackelford, if you're watching, I see you asking about questions 12 and 13 on the explain. Again, I went back over the explain. All right. 12, we're taking a look at what would the effect be with a 5-degree tilt in the moon's orbit around the Earth. And then 13, why would we still have an eclipse? Because like I said, these are cyclical. Even though the tilt prevents an eclipse, you're still going to have that tilt kind of wobble back and forth. All right. Can we submit our DNA sheets? Absolutely, Hike. Once you guys are done, you have 1, 2, 3, and 4. You have notes at the bottom. Okay? You've rated yourself. Turn your DNA sheet in. Okay? They are due today before midnight, but absolutely, if you're done early, turn them in. Like 6 people in period C have done already. Okay? I mean, you want to look at your own period. I'll talk about period D tomorrow. People in period D. 6 people have turned them in. Right? So turn them in as you do them. I can take a look at them early. All right. Does the sun affect other tides? Says John. Yes, the sun affects tides for the spring tide. Right? The sun adds to the gravity and the effect of the moon during a spring tide. That's why we get higher than normal high tides and we get lower than normal low tides. Okay? New moon was actually earlier this week, so we were in a spring tide. We're transitioning to the first quarter, so right now tides are kind of normal. When we get to first quarter this month, then you're going to start to see that neap tide. So if you're near any kind of coastline. All right. I've been trying to take a look at Myrtle Beach. I posted the pictures yesterday between the tides. You can kind of see the effect. This was, again, sort of near neap tide, but not quite, and the timing's a little off, but you can see the change in the sea level just between the daily tides. All right. If the Earth had more than one moon, how would tides work? Well, it'd be a more complicated version of this diagram, Hike, because each moon would have an effect on the tides. So, like, let's say if the Earth had a second moon, all right, if the moon was over here, depending on its size, would depend on how its effect and the distance too, right? So if it's really, really big but really, really far, it's not gonna have much of an effect. If it's really, really big and really, really close, it's gonna have an enormous effect. So, like, let's say we add in another moon. I need another color. I'll make it brown. It's a really big moon and it's really, really close. Now, all the water is over here. High tide's over there. Low tide, low tide. So the sun would add a little bit to that new moon's tide, all right? And it would be more of like an even balance probably, all right? The more you have all over the diagram, you don't have to draw this in. Do not draw this in, okay? The more you add in, the more you're going to have different water getting pulled different directions. You can't create water, you can't destroy water, but you have to take it from the same source, all right? If you had the moons in alignment, then you would have a massive spring tide. Okay, so if you had a straight alignment, massive tide. If they're all at different angles, you'll have weaker tides. All right. Actually, when you have a bunch of objects in alignment, it's called a syzygy. Massive gravitational effect. It's a fun word, syzygy. All right. That and my other favorite science word is ploidy. How many chromosomes an organism has? Our ploidy number is 23 as humans. So we have been saved from less complicated diagrams to memorize. Yes, you have. Even though the Earth does have a second moon for the next year or so. That was an article a couple weeks ago. It's pretty cool. We captured an asteroid temporarily, and it's kind of in the same path as the Earth, and we call it our second moon. Periodically, we pick up a second moon, but not enough to be considered in the Sun, Earth, Moon, Moon system. Just Sun, Earth, Moon, our big moon. All right? You think life is elsewhere? Sentient life? Don't know. There's a lot of space. If there is sentient life, probably won't communicate ever with each other. Bacterial life? Yeah. Where? I don't know. Pretty interesting. I think Mars had it in the past. Bye, Ryan. I think Mars had it in the past, and maybe it's on Europa or Enceladus right now, or maybe even Titan, moon of Saturn. Those other moons were moons of Jupiter. All right. All right. So your agenda again. We've reviewed the DNA. You did that first. Done. We reviewed the explore section, Modeling Eclipses. Done. Fix your answers if you have something wrong. 3, or you're incomplete. Complete the explain section. That's on you to do if you haven't already done it. There's only 3 questions. Hopefully you're good. All right. That's today. It's over. Again, you can rewatch this to get help again, or you can email or go through reminds. Tomorrow, you will update your key term guide as number 1. Number 2, you will take the weekly quiz. I'll be posting it, the DNAC 22. I'll be posting that in Classroom around 10 a.m. around the start of our stream. I'm still going to have a stream. And then third, you're going to work a little bit into the extend section. Extend section's long. You're not going to do the whole thing. There is 7 questions. We'll do probably half. Maybe I'll go over the explain and just have you guys just do a couple of the extend. We'll finish modeling eclipses on Monday. There's only 2 evaluate questions. So we'll finish up the extend section and the evaluate section on Monday, turn it in before the end of the day. And then after that, we are done with the phenomenon of the sun, earth, and moon. We will be working on our study guides Tuesday, Wednesday, Thursday, Friday of next week. There will be no DNAC because we work on the study guide. You'll have a test coming up. All right. It'll be April 7th, Tuesday. All right. Monday, before the test, we will do a live quizzes. I'll host the quizzes on stream. You guys can compete in it. I'll be going over the study guide entirely. All right. I'll have the DNA question be one of the study guide questions next week. We'll go over the entire study guide. We'll do a quizzes, and then you guys will take the test by a Google form on Tuesday. All right. Any final questions? You guys are hurting me. You're hurting me. Flat Earth. Good thing Sissione's not in here. I'm probably just going to end it before this gets worse. See you guys tomorrow. Bye, Rainey. Bye, John. Bye, Kaylee. Bye, Zazra. Bye, Donnie. Mia showed up. Hi.